In this lesson, we will complete our stopwatch project. We will introduce a push button switch which will act as the control for our stopwatch. Pushing the button gets the stopwatch going. Pushing again stops the stopwatch. If we push the button, we will continue off where we left off. To reset the stopwatch, just hold down the button for 3 seconds and then it will restart at 0. Let's take a look at the objectives. By successfully completing this project, we will have mastered the following items. You will understand how to use the Stopwatch third-party library, which is a library we will be including that will help us with timing accurately. We will put all the components together to create the stopwatch, a push-button switch, shift register, and 4-digit 7-segment display. If you are ready to begin, let's get this project started. Here are the parts we will need: an Arduino Uno, a USB cable, a breadboard, a 4-digit 7-segment display, an 8-bit shift register, and we'll be using the 74HC595 shift register, 7 to 20 ohm resistors, a push-button switch, and connecting wires. Let's take a look at the circuit diagram. From our previous shift register circuit, the only addition we'll have to make is our push-button switch. It requires just 2 connections. One end of the switch goes to ground, and the other end of the switch will go to pin 5 on our Arduino. That's it. That's all the additional connections that we will need for our circuit. Let's go ahead and make the wiring change needed to complete our stopwatch. All we need is a push button switch, so I'll go ahead and include that. This will be the control for our project. One end of the switch goes to ground. And the other end of the switch goes to pin 5 on the Arduino. That completes the wiring. Those are all the changes we'll need for this project. Okay, let's go ahead and upload the code for our stopwatch. Alright, now it's done. To get the stopwatch going, we have to push the button. So I'll go ahead and push the button. As you'll see, it's incrementing in time, 4, 5, 6, and so forth. And when we want to stop the stopwatch, we simply press the button again. And you see, it stops on 12. I'll continue. It continues from 12 going up to 21, 22, and so forth. Stop it again. I'll continue. I'll let it go all the way up to 59.60 for the first minute, and then you'll see the 3rd digit increment to 1. Okay, here we go, 59, and there it goes. So that's going to increment to 1, 2, and so forth, and it goes all the way up to 99 minutes, and then it's going to reset all the way to 0. So that's how it works. To reset the stopwatch, you just push the button and you hold down for 3 seconds, and then you see it starts back at 0. That is what resets it. And if you push on start again, you start from 1 again. Alright, so I'll go ahead and reset it again. You hold down for 3 seconds and you let go, and that resets it. So that's our stopwatch. Okay, let's take a look at the code for our stopwatch project. So initially at the beginning, we have a couple of third-party libraries we need to include: the Stopwatch library and the Bounce tool library. We've seen these before and we've installed them before, so you can refer to the previous lessons for how to install these libraries. I will provide the links to those libraries in the resources section of this project. Next, we set up our segment pins and display pins. All of this code we have seen in our last project. What's new is the button pin, which we have to define is connected to pin 5 on the Arduino, and we create a bounce object and a button press timestamp global variable that we'll use to keep track of our button presses. Continuing on, we have our digits array, which we use for the LED mappings, and we then continue on with setting up the shift register pins, latch on pin 8, clock on 7, and data pin on pin 6. Then we create our stopwatch objects, and we pass in the stopwatch seconds argument for the first stopwatch, which is what we'll be primarily using. Into our setup function, we initialize our 7 segment pins and the pins for toggling the LEDs, and then we turn off our 7 segment displays. All of this code you have seen previously. Then we enable the internal pull-up resistor on our button pin, so we set the pin mode as input pull-up for our button pin, and we attach the button pin to our the bouncer instance. The shift register pins are set as output. We set up the byte representations for our digit files, and then we are finished with our setup. In our loop function, we first update the bouncer instance, and that just gets it ready to take input from our switch. If the switch fell, if the bouncer dot fell, of course a button press occurred. So we first want to determine if the stopwatch is running. If that's the case, if it's running, we want to stop it. Otherwise, restart it back. If the bouncer rose, that means that there was a button press. We also want to check for how long the button was pressed. If that was greater than 2 seconds, we want to start over our stopwatch. Let's quickly jump to the start over function. So start over takes a Boolean value, which is start count, and basically if this is true, we will automatically restart our stopwatch. Otherwise, if it's false, we will just pause where it's at and leave the inputs at 0. So in here we would reset our stopwatches, and again, if start count is true, we will automatically restart our stopwatches. That's if you reach the limit, which is 100 minutes, you'll restart back at 0 and the stopwatch will keep going. Otherwise, we will stop and set our inputs or set our global variables as 0 and wait for the user to re-engage the stopwatch. Okay, so let's get into our the logic for determining how we set the digits. So if we have reached 6,000 seconds, which is 100 minutes, we would want to start over our stopwatch. So we call start over, passing in true, and it will automatically start over from 0 and start our stopwatch. To get the value for digit 1, to get the number of minutes, we do display value divided by 60 would give us the number of minutes, and that divided by 10 will give us our first digit. For our second digit, display value divided by 60 will give us the number of minutes, and modulo 10 will give us the remainder. So if, let's say for instance, 12 minutes have passed, after we calculated display value divided by 60, we get 12. 12 modulo 10 will be remainder of 2, and that's how we get that 2 for that second digit. For the third digit, we do display value modulo 60, right? That will give us, how many tens of seconds there are, and when we divide by 10, we'll get that third digit. And finally, for the fourth digit, we do display value modulo 60, which would get us the number, which we would then perform a modulo 10 to get us the remainder. So as an example, if display value is 23, 23 modulo 60 would be 23, and 23 modulo 10 will give us 2 remainder 3. So that's how we can extract that 3 value to show on the last digit. We then call the update display function, passing in the digits we want to display, and this all works exactly from our previous shift register circuit. So that was the code review for our stopwatch. To summarize, in this project you learned how to create a stopwatch using a switch, a shift register, and a 4-digit 7-segment display in conjunction with the Arduino. You were also introduced to the Stopwatch third-party library. It was a challenging project with a lot of wiring, but I hope you had a lot of fun doing it. Let's move on to our next project.